Okay, so this video is going to be on lesson 6.3 exponential and logarithmic forms of equation, and this will be for my pre-AP class. Make sure that you're watching the right video, pre-AP. And for examples like that, you are not allowed to use a calculator. So for this lesson, we will not be using one. So let's start for the first one. If you want to solve something like this, 3 to the power x is equal to 9. Now you ask yourself, what should 3 be raised to what power for me to get a 9? And the answer is 2. So that was pretty simple. The exponent for this problem is 2. Now let's try to solve the other one. 3 to the power x is equal to 7. Now what power should you raise 3 to get 7? Now this one is not easy to find, and that's why log can be used. So before we move on to log, I'd like to review with you what each of those is called. So this is called the base. This is going to be called the exponent. This is going to be called the answer or argument. So let's write them down. This is going to be the base. This is going to be the exponent. And this is going to be called the answer, or in some cases we're going to be calling it the argument. And we're going to see how we can use the log to find the x. Now let's look at the second example. Can you try to find a pattern? 3 to the power 2 is equal to 9. To write it as log, you would put log base 3 of 9 is equal to 2. 2 to the power 5 equals to 32. You can write it as log of 32 base 2 equals to 5. Or 5 to the power negative 2, which is equal to 125. You can write it as log base 5. 1 over 25 is equal to negative 2. So did you see a pattern? The base, which is 3, where does it go? The base, which is 3, it goes to be the base next to the g, so you write it in small, as a small 3. The exponent, which is 2, is written next to the equal sign. And the 9, which is the answer, is going to be inside the log. So did you see a pattern? Again, the base is written in small next to the g. The exponent is on the other side of the equal sign, and the 32 is inside the log. Again, 5, negative 2, and 125, the base, written in small number next to the g. The exponent is on the other side of the equation. 1 over 25 is going to be inside the log. So let's see what we have noticed. How can we write this? Based on these examples, write a general rule using the words exponent, base, and argument. Before I do that, I would like to take some time to see how you can be switching between the log and the exponent. So let's try to do that. So if you have 5 to the power 2, and that is 25. So log, what you can do is that the base goes there, and you write it in small handwriting. The 25 goes inside the log, inside parentheses, and then the base, the exponent, is going to be 2. So let's see if I want to shift between log and exponent. How is this possible? So if I say log, and I have a 5, 25 on the inside equals to 2. Do you see that? 5 to the power 2 equals to 25. I think this will help you see it better. 5 to the power 2 is equal to 25. You see that? Now let's try another one based on something that we had over here. So log 2, 32 equals 5. I think this will help you see it better. So if we have log 2, and this is 32, is equal to 5. Again, 2 to the power 5 is equal to 32. So 2 to the power 5 is equal to 32. This way helps you see the comparison between, or how you can change from log to exponential. It's easier than when you look, sorry for this mess. Okay, it's easier than when you look to change from exponent to log. I think this will help you see it better. So let's, from this, let me try to write a general rule. So if you have a base and you raise it to an exponent, it's going to give you an answer, or we're going to start calling it an argument. Okay, so log and the base would go down there in small, and the argument is going to be inside the log, or the answer, equal to the exponent. So the answer of the log is going to be the exponent. So for example, if I give you an example like that, log of 2, and there's a 3. So you ask yourself, well, let's say that this is not given and you try to find it. The log would mean, what should shout, what is that? So what should 2 be raised to get an 8? Now that's a messed up question, but you can say 2 to the power what would give you 8? Or log would also mean, how many 2's do you need to get an 8? So how many 2's do you need to get an 8? I think this is a better way of writing it. So let's just remove this and let's write it again. So log 8, 2 is equal to what? You would ask yourself, how many 2's to get an 8? Or what should be the power of 2 to get an 8? And the answer would be 3. So as you can see, log is basically exponent. This is just another way to say it. Now that you are familiar with log, let me try to switch now between, write each equation in exponential form. Again, to switch from log to exponential, you would say 2 to the power 3 is equal to 8. 2 to the power negative 2 is equal to 1/4. I think you get the concept, so go ahead, try to do the rest on your own. Again, 2 to the power 0 would be 1. And so go ahead, do the rest. But I would like to review some concepts with you then, before we move on. So we learned 2 rules today. Go ahead, write them down. Rule number 1 is to switch between the log and the what? The exponential. So log of base, and this is the answer or the argument, is equal to c. In order to change it, you would say b to the power c is equal to a. So b to the power c is equal to a. Now this is the first rule that we learned. I'm going to write the rules as we go. So let's move on to the next equation, and you have the power. So you need to change this to an exponent or to a logarithm. You have it in exponent and you want to change it to logarithm. So you say log, and the base 2 goes down there. The answer is here, and equal to the exponent. So log always give you exponent. Now let's try another one. Log equal to the exponent. the base goes there in small handwriting, and then the answer is over here. Now, a common thing that I see most of you do, that you don't write this small enough so it seems like it's 2 to the power half. You have to be careful. So the 2 has to be small enough and it has to be written next to the G. So when somebody is reading your log equation, they will not think that whatever you're writing, it's log 2 to the power half. You have to make sure that it doesn't look like that. Now, let's move on. So 5 to the power 0 is equal to 1. Again, you would write it as log is equal to the exponent, and the base goes here small, and you would put 1 over here. So I think this will always be 1 every time the exponent is 0. So 5 to the power 0 is equal to 1. So it can be safe to say that no matter what number you have at the bottom of the log, even if you have like a 6 and you have a 1 over here, the answer is going to be 0, because 6 to the power 0 is 1. So every time you have a 1 inside the log, no matter what the base is, whatever it is, remember, anything raised to the power 0 will give you 1. So if I had a base of 50, then I will directly know that the answer is 0, because 50 to the power 0 is 1. So remember, so this is one of the rules that we can come and write over here. So this is another rule that we can, so let's say rule number 2. Every time you have a log of 1, no matter what the base is, the answer is 0, because b to the power 0, no matter what b is, it will always give you a 1. Now, let's move on to number 12, and we can also deduce a rule from here. So log, the answer is going to be 1, and as you can see, the base is 6 and the answer is 6. So as you can see, the only 6 to the power 1 is equal to 6. Now let's try another one. What if I have log 7 and there's a base 7? So I can safely say that the answer is 1, because since the base and the answer or the argument are the same, let's try it. 7 to the power 1 is 7. So again, we can conclude another rule. So we're going to call it rule number 3. You don't have to memorize them in order as long as you recognize them. So every time the number or the argument matches with the base, you can directly say that the log is 1, because b to the power 1 would be itself. So this is another rule that you need to know. So I think this is enough. Okay, now let's move on to the back page. Now I have to read this, and you have to read it again. You have to evaluate this without using a calculator. So you have to show your work. And in order to solve a log, it's always better to change it into an exponential, and this will help you solve the log. So for example, for number 13, you ask yourself, 10 should be raised to what power to get 1,000? And the answer is going to be 3. So I'm going to do 13. I want you to try 14 on your own and 15 on your own. Now I'm going to try to do 16. Now, you ask yourself, 4 raised to the power what will give you a negative 16? So I'm going to write question so you don't think that this is a negative. This is not a negative. Okay. So 4 to the power what will give you negative 16? Now, first of all, I'm going to think of 4 to the power what is going to give me 16. Let's start with that. So 4 to the power 2 is 18. 4 to the power 3 is 16. So 4 to the power is equal to 16, but I don't need 16. I need negative 16. So you ask now yourself this question. What do we know about the domain of a log? Remember? The domain of a log goes to be only positive. Can you have a negative inside the radical? No, you cannot have a negative. You cannot have a 0. So then there's no solution for number 16. So that's it for number 16. Now let's move on to 17. I want you to do this on your own. I'm going to try to do 19 with you. Now, 9 to the power what would give you 3? Okay, now to get from 9 to 3, what do you do? So this is what you need to think of. You need to square root 9 to get 3. So if I want to change square root into a power. Remember, this is going to be 1, and this is like, you assume it's 2. So it's 9 to the power half would give you 3. So log of 3 base 9 would be half. You got it? So we did 19. I want you to try 16 and 18 on your own. And you know what? Let me do 20 for you. So I'm going to be doing 20. Now, 16 to the power what would give you a half? Now, as you can see, half is way smaller than 16. I'm not going to think of half right now. I'm going to think of 2. I think it's easier to think of it this way. To go from 16 to 2, you don't raise it to a whole number, you raise it to a fraction. So basically you need to think of a radical. So square root of 16 would give you 4. So it's not square root of 16. 2 should be raised to what power to get 16? To the 4th power. So 4th root of 16 is equal to 2. Because 2 times 2 times 2 times 2 is 16. So 4th root of 16 is equal to 2. So you can write it as 16, 1 over 4. You see that? So 16 to the power 1/4. Remember, what do? You do the power on the inside over the power on the outside. So there's a couple of things from Unit 4 that we need to review. Now, so 16 to the power 1/4 would give you 2, since this 4th root of 16 is 2. But I don't need 2, I need half. So I'm going to write this again. I'm going to erase this. Let me remove this. Just wanted to remind you of that. I don't need 2, I need half. So in order for this to flip, do you remember what you need to do? So in order to this to flip, like remember it's 2 over 1. So in order to this to flip, then this should be negative. So 16 to the power negative 1/4 would give you a half. So the answer is negative 1 over 4. Now I want you to review this again. We'll do more practice when it comes to number 20. So that's it for the first part of this question. Please go ahead and continue the rest on your own, which is 14, 15, 17, and 18. Now I'm going to be doing, let's say, number 21, okay? So again, to solve something like this, you need to change it to exponent. We need to find n. So 8 to the power 4/3 would give me n. So again, one way to solve a logarithmic equation is to change it to exponential. Now, this might, you say to yourself that this looks complicated. But look, 8, you can write it as 2 to the power 3. Because 2 times 2 times 2 is 8. So instead of 8, you can put 2 to the 3rd. And then you raise it to the 4/3. Now remember, the 3 and the 3 cancel out. You are left with 2 to the power 4, which is 16. So n is 16. Now go ahead, try 22 on your own. I'm sorry, maybe this is a long video. I'm sorry for that. But this is a very important lesson, and it's a preparation for later on. I know there's a lot of equations, so we will do more practice tomorrow in class, and see you tomorrow.